All right. I think we're on time, so it's ready to go. Thanks for coming for my talk. Seeing you all here, I'm ridiculously nervous now, but we'll try and get past that. But yeah, welcome to my talk today. We're going to be talking a little bit about the open source supply chain, the risks in the open source supply chain, in particular with malware, and how AI is changing that game and causing havoc, basically. A little bit about me. I'm from Aotearoa, or New Zealand, originally. I live now in the Netherlands, though, just to keep everyone guessing. I'm the former co-founder of Compago, which does still exist, but just after 4 years, they decided I need to find some new hobbies. So I did. And I'm a researcher and advocate at Aikido Security now. You can find me anywhere on social media as Advocate Mac, and I'm also the host of the Secure Disclosure podcast. This is my plug. There's one more plug for my podcast in the presentation, then I promise I won't talk about it again. But I want to start off just by going a little bit into understanding the open source supply chain that we're dealing with right now, and why it's such a challenge, in particular when it comes to things like malware. So you probably know this, and numbers like this get thrown around, but somewhere between 70 to 90% of all of the code that makes your application do its thing comes from open source kind of projects. And there's various levels to this. You have your direct dependencies. These are the projects that you choose. You know what they are because you picked them, you looked at them. But then there's transitive dependencies, which are the dependencies that the open source dependencies depend on. And then we also kind of have at the bottom level things that we would call foundational projects, things that are pretty much in everything in that ecosystem. So a lot of security, when we're building out our applications, we offshore a lot of trust to other people. And this is great. I'm definitely not ever advocating against the open source supply chain that we have, but it does mean that we have limited control over the security concerns for somewhere between 70 to 90% of our application, which is quite alarming. And we can kind of visualize this a little bit. We have our application. Our application has open source dependencies. They have open source dependencies, and they have open source dependencies. It typically can go back about 30 layers, but I couldn't get the icons to go any smaller, so I stopped at 3. But in addition to that, we also have things like third-party services, which also have open source dependencies in them, just to confuse it. So if we include all of that, we have this huge ecosystem that our application is relying on to do its thing. Now, at the moment, this kind of looks manageable because I have my dependencies and they're nicely packaged with their dependencies. And then over here, I have third-party services. But what I actually did is I decided to create an accurate representation of what this actually looks like in a real project. And this is that. And that's because open source dependencies are dependent on each other. Third-party services have dependencies, and it's this kind of chaos. And it's very, very difficult to even understand what we're dependent on, let alone try and manage it and get through it with it. So if one of these transitive dependencies way down here suddenly gets turned malicious or has a big vulnerability within it, I'm just going to think of a random name off the top of my head. Let's just call this log4j. And what kind of happens is that can have an upstream effect that will then turn all of these other things vulnerable or malicious, depending on if it's malware or a vulnerability, which of course can turn your application vulnerable or malicious. So this is kind of what we're dealing with right now. And unfortunately, AI has actually made this much harder to understand and control. So it's not really a security conference until someone shows this meme. It's very popular. This meme became so popular that it sparked a term called the Nebraska problem. And that basically just means that the Nebraska problem is that we have a project that someone's thanklessly maintaining, and we're relying on them a whole lot for security. And we can even kind of name some of these. Xutilis, log4j I've talked about, debug is another one that kind of hold up the internet. There's been some new iterations of this. Every time there's a breach, something new comes out. We're currently onto this version. I don't know what will be the next version, but it's going to keep getting worse. And AI is really kind of like creating a big problem when it comes to the Nebraska problem that we're trying to deal with. And so what I want to do is I just want to talk about one of these projects just for a minute, one called Debug. Now, Debug is a Node project. It's maintained by a foundational developer, a really great guy, and someone that most of applications would actually rely on at some point, called Josh Junon. And Debug is one of the most popular projects that gets downloaded on NPM. So each week, it has 476 million downloads to it. It's got a long version history, so it's kind of very credible. It's got lots and lots and lots of dependents. It doesn't have a lot of dependencies, which is another good sign. But this is as legitimate as you can get. And even if you could decide that you didn't want to use this, you kind of can't because it's pretty much in everything. So what would happen, God forbid, if some bad actor managed to compromise Debug and put malware inside of it? That would be a pretty catastrophic day, which is exactly what happened. So if you'll see down here, this was first detected by researchers at Aikido. And we found that there was this very weird-looking obfuscated code down here. And if you look at the scroll bar, it goes on for a very long time. And this was injected, this one line of code was injected into all of Josh Junon's projects, which wasn't just Debug. There was multiple of them, which together, I'll show them in a minute, but together they constituted around about 2.6 billion weekly downloads. So this is probably one of the largest supply chain attacks that we've ever seen in terms of the volume of downloads. And nothing really too much happened because of this. I'm not going to get into it, but basically we got very lucky in this one. That the attackers were quite incompetent in what they were trying to do. But the impact could have been really severe. And then we have to look at kind of how do we try and solve this problem at the moment? How do I know if one of my tools in my supply chain has been compromised or has a vulnerability in it? And how we've typically done this is that a vulnerability has been found. So security researchers will often report them, or maintainers themselves will report them when they find a vulnerability or if something gets compromised and it's reported. And then a CVE, Common Vulnerability and Exposure Number, is created. What then happens is that we have something called SCA tools, software composition analysis tools, that looks at all the packages our software depends on, looks at all the databases like the NVD, National Vulnerability Database, and sees, does this package version have a connected CVE report next to it to say that there's something wrong with that package. Maybe it creates something like an SBOM so we can see it, and it's kind of pulling that from our information. That's how we typically deal with it. This no longer works really anymore. So if we just take kind of a look here at the CVE, this is the CVE for Debug that came through. And there's lots of other ones. This is probably the most famous CVE. This is for Log4j. And this is typically how we do it. This is what they look like. This is the information it pulled. It has about what's happened in there. It talks about the version numbers that are affected. And this is typically how we've secured our supply chain. Oh, yeah, here's a fun fact. Log4j happened December 2021. There was a study in December 2023 that tried to figure out how many applications were still using the vulnerable version of Log4j, and it turned out that about 30% were. So I just find that kind of wild because it just lets you know the kind of battle that we're fighting here. But these CVEs no longer work in a kind of an AI-powered malware world. So what actually happened with Josh? So this is Josh Junon. He got phished with this phishing email here, which came from support@npmjs.help. I've done an interview with Josh to talk about it, but a number of things just basically happened at the same time. He was off to a medical appointment, he was in a rush, he got this email, and just so happened that he thought, well, this is something that I could do whilst waiting in the lobby, so he, on his phone, updated his password, and then that's how he got phished. And because they were using time-based MFA, they were able to kind of get past that as well. And then Josh lost access to his account. In total, these are some of the packages that were compromised. So Josh is a very prolific maintainer. And I really always want to make clear that mistakes happen. And I think we can all agree that like the world shouldn't depend on one guy thanklessly maintaining these packages for everything to collapse. But around about 2.6 billion weekly downloads happened here. And what's kind of interesting just to talk about this is, you know, Josh at no point made a decision that he wanted to be one of the most prolific maintainers ever. He created some packages at university, they got popular, then he kind of got stuck maintaining them. He's the epitome of that thankless guy maintaining them. Anyway, that's what happened. We first made this public on September 8th. So September 8th, we reported our first thing to say that Debug and Chalk were compromised. The CVE came out 7 days later on December 15. So for 7 days, none of these kind of traditional tools would have been able to tell you that you were using a malicious version of Debug or Chalk, and unless you were using kind of some modern malware detection tools, you would have kind of been completely unaware of it. And I want to kind of really highlight why this is so important, because I want to go through the whole thing of how quickly it all took place. So within 30 minutes, we had notified Josh. We were trying to message him everywhere. Blue Sky ended up to be the winner. So we contacted Josh. He then went about trying to contact NPM because he had lost access to his account. It took about 4 hours from the compromise before Josh was able to regain access to his NPM account through the NPM support. And then it was about 4.5 hours later from the initial compromise that all of the malware was gone. So we're literally talking about 4.5 hours. Now that doesn't sound like that much. And it sounds like maybe we could have avoided this and not much would have happened. And you would think that, but we move and live in a very, very fast world. So what was the actual impact from this? Well, the good security folks at Wiz actually did some great post-analysis on this, and they were actually able to look in and see how many of their cloud accounts actually had the malware inside of it and how much like total impact was there. So 10% of all of the accounts of Wiz had the actual malware inside them. So 10% of cloud accounts. You kind of have to be a little bit cautious with language here because it doesn't necessarily mean that like 10% of all the internet had this, but it's just a huge proportion of the number of accounts, of cloud accounts that had this malware in them that was only around for 4.5 hours. And 99% of the accounts actually had exposure to one or more of the packages, which is kind of insane. So this is where we're talking about. So now we go back to that CVE that was created 7 days later is not really worth anything. And that's not to say that CVEs don't have their place. They're great for vulnerabilities. But when it comes for malware, and particularly at the speed in which we're dealing with malware, it's really a losing battle in trying to rely on that old system to keep us up to date at the moment. So we're really dealing with malware at the speed of AI. And there's one thing that can really great, that you kind of can see this, is that this graph here shows the amount of malware that was discovered in open source over a period of time. And you can really see kind of coincidentally when AI started to become very, very popular in terms of coding experiences, that this graph absolutely shot up endlessly. So the amount of malware that we're actually dealing with in the ecosystem right now is more than we've ever dealt with before by huge factors. And we're trying to deal with it. So old systems like CVE numbers where someone has to manually review of it is not really going to get us there anymore. And typically what we're really seeing is that there's more or less 3 core ways that we're seeing predominantly AI being used in malware. So the first one that I'll talk about is when AI is being used as an on-victim tool, meaning that this is when the AI itself is the thing that is acting maliciously. The second thing, which is kind of hard to talk about, but is definitely there and present, is that AI is a productivity multiplier. So the threat actors are dealing with this in the exact same way that other coding companies and everyone else is dealing with the productivity multiplier. So we're dealing with more and more malware. And we're also seeing things like more and more professional phishing emails, README pages, anything that would kind of suggest that this may be dodgy is very hard to identify now. And then also AI is an evasion mechanism. So there's something there called polymorphic malware or on-demand malware, where this is where AI tools are able to create malware kind of specifically for use cases. So I want to take a look at and some examples and go into some case studies here of each 3 of these examples that we see. So the first one I want to talk about is AI as an on-victim tool. And for this, I want to use the Singularity case study. So Singularity started with a compromised NPM package called NX. Now, NX is a tool to help you organize and manage massive repositories. So NX uses AI a lot in its actual tool, which is interesting. That comes later on. So NX was compromised by a threat actor via the theft of their developer tokens for this package. And this actually evolved. So NX was the first one called Singularity that happened on 26. It would then kind of morph into the Shah-Halud worm. So this is the same malware in a previous iteration. So the Singularity attack wasn't a self-propagating worm like the Shah-Halud attacks were later on. There was Shah-Halud 1, 2, and 3. But this was the original kind of mechanism for it. And they had some very specific AI use cases in this first version that didn't appear later on. But basically, all that happened was there was a post-install script that loaded something in this file called telemetry.js. And then the goal was to harvest credentials and then publish those credentials in public repositories on GitHub. It was particularly nasty. This particular attack got 2.8 thousand repositories published publicly on GitHub. So this is the same approach that the Shah-Halud worms that would follow would take. And basically, one of the reasons why they're doing this is GitHub is actually a great C2 server because it's a trusted domain. And also, it takes a lot of fog of war. When you publish things like credentials publicly, it makes it very, very, very hard to be able to identify and attribute attacks back to a single source anymore because everyone's basically had access to them. So that was kind of what was happening. So it was a pretty nasty attack, and it was the first time we had really seen these credentials being published publicly on GitHub. But I want to talk about how they found those credentials and how they published them, because it's really quite interesting, and I think it's going to be the start of what we will really see more and more. This is the telemetry.js malware. It's kind of interesting. I'm not going to go into all of it. All I want to do is kind of look here at line 9, which you probably can't read, but I have blown up. But line 9 is just a prompt. And that prompt is saying, hey, I want you to recursively search all local paths, basically find credentials. So the mechanism of actually finding credentials in this case wasn't done by a tool like there's GitLeaks or TruffleHog. It was actually done by an AI model that was already installed on the victim's machine. So they didn't even need to pull it down. So they were using either Gemini or Claude. And so this relates back to what NX was actually doing and why they could have confidence that these tools would actually be installed on there. It would then use the AI models that the user or the AI clients and agents that the user had installed to actually search for secrets and then give them back to the malware so that they could publish them on GitHub. So it was a really interesting use case, whereas one of the first times where an AI model that was on someone's machine or in their environment was actually used by the attackers in a malicious way. And definitely like the first that we've seen of this happening. So this is kind of like one mechanism of using AI as a kind of on-victim tool to be able to spread malware. And we'll talk a bit more about this later on when it comes to kind of the self-propagating malware, but we will get back there. There's another way that they're actually exploiting on-victim tools, and this is more or less exploiting a work path, which is exploiting hallucinations. So there was some research done by GitHub a while ago that said 97% of developers are using AI coding tools, which I took as 100% of developers are using it and 3% are lying about using it. But anyway, this reliance that we have on AI tools, again, whilst it's great for so many areas, does expose some flaws, and attackers have figured out some very interesting ways of being able to exploit the tools that we're using and their weaknesses necessarily that they have. So the first thing we need to talk about is what is AI hallucination. So this is a very famous quote about AI hallucination that says, AI hallucination is akin to the shadow that looms large but lacks substance. It mimics a semblance of reality, yet veils the essence of truth, which of course is a quote from Abraham Lincoln, or at least it is if you ask ChatGPT to provide a quote that Abraham Lincoln did about AI hallucination, right? So this is just a funny way of just showing you that AI is eager to please. It doesn't necessarily know what's true and what's not. And the way that they make relationships in their vector databases often kind of attribute to hallucinations. And there are ways around this to improve it, but at its core, they will always be susceptible to this kind of hallucination, which means that we need to have verification steps on there. But anyway, moving along. I want to ask a question now is, if you're building a project and you've got a specific use case, you're trying to connect to a specific database, or you're trying to use a specific tool, but you don't necessarily know exactly what open source tools are out there. Now, back in my day, we might have used something like Stack Overflow, asked questions, and got some lists of some reputable tools through that. We may have searched it ourselves, but now we can just do things like ask ChatGPT, hey, what are some tools that are available for this? And ChatGPT is very good at clients. So I have a small little demo here where essentially I'm just asking ChatGPT that I have a node project and I want to connect to an Orient database. I know that that's a bit weird, but anyway, I asked it to do it. And then what it gave me was a whole bunch of recommendations, including the install code for each of them, and also the advantages that each tool had. So I wanted to know, hey, which ones are these? The problem, though, is that when I went to install these packages, I would get a 404 error. And that's because the packages didn't actually exist. Whilst ChatGPT is able to give me a list of all of the advantages that this package supposedly has, out of the 4 packages, 3 of them didn't actually exist. They were all just hallucinated. And they were kind of hallucinated in a way where I guess the relationship is that if this package did exist, this would be what it would be called. And so that's where we are. And so here we are, just kind of showing that we can see these here. So how do attackers actually leverage this? Because at first it seems like, well, what's the threat here? Because the threat seems that, well, all we'll get is an error, and then we'd eventually figure out that the package doesn't exist, and we'd move on. But we have to kind of go back to a pretty basic supply chain attack called typo squatting. Typo squatting still exists, it's still very, very prevalent, but it's kind of on the lowest level of sophistication. So for example, there was a cryptocurrency development kit called CC14, and then someone created CCTX, right? Just to try and trick people into putting in the wrong package name in there. And then what a typical typo squatted packet does is it does what the original one does, but just sprinkles a bit of malware in there. So that when you put it in your project, everything runs normally, you're just not aware that there's also some malicious activity happening as well. So what does this have to do with hallucinations? Well, there's something called hallucination squatting. Now, officially, it's actually called slop squatting, but I find that so disgusting, I refuse to say it. So I'm calling it hallucination squatting. But it's basically when an attacker will find a hallucinated package, they create that package with the exact same name, and then the developers, you basically have your AI model advertising your malicious package for you. Because more and more, we're relying on that mechanism of doing it. And then you kind of have this period where even if you did add additional checks on this, so let's say you were smart and you go, before I run this install command, I'm going to check that this package exists with an agent. But what an attacker can do is they can just find all of these that are typically hallucinated by the models and start creating them. So then everything's still going to appear legitimate. So we create a package. If you're smart, you would create the package so it did the thing you expected it to do, but sprinkle in some malware. And there's some great research. The best research that I like comes from LSU Security. So if you want to go deeper into that, they have some good articles. And they came up with a really good export flow for this, which is basically take all of the questions on Stack Overflow, put them, well, relevant questions, put them into a model like ChatGPT or whatever, get a list of the hallucinated packages, obviously automatically, and then create the packages themselves. And they also recently did this, and they discovered that 20 to 60% of packages are hallucinated. I know that's a big number, that's depending on the model that you do. So Gemini had the highest number of hallucinated packages, and unsurprising, Claude had the lowest number for that as well. But it's still a very, very high number of packages that are actually hallucinated. And they even have recently done some research at LSU Security where they went out and they created one of these malicious packages and well, it wasn't malicious, so they just created one to see how many people would download it, and it got downloaded 50,000 times. So it's definitely a viable exploit path of using AI as kind of a tool that the victim is using to ultimately get malware delivered onto their machine. Now the other one, which is kind of self-explanatory, it's a little bit hard to kind of talk about in great detail, and it's basically the increase in productivity. So the best example that I have is the same kind of graph that I have talking about here. And when I was building up these slides, I was going to show there's lots of ways that you can kind of do this. where you just have a nice looking README or a nice looking phishing campaign. But basically, there's not really anything to show here other than areas like phishing emails are getting harder and harder to detect. It's quite funny. It used to be, like even just 3 years ago, that you were trained or you trained your staff to detect a phishing email based on if there was things like spelling mistakes in there. Now it's kind of like the opposite. If I see an email with a spelling mistake in it, I kind of feel like it's more legit because there's more chance that a human like wrote it. So we've kind of done a complete 180. But we're really seeing the massive productivity gains from this. And other areas that we're seeing this is not just when attackers are creating malicious packages. Obviously, they immediately get a really nice README. They can create a package that actually does something. So it's not just malware. They can start off dealing with that. They can also just create a whole bunch of bloat. So I was going to show some examples on here, but it's not that interesting. It's just really crappy code that's really like big. And it basically just makes it harder for researchers to be able to find malware because it's buried in just huge amounts of bloat everywhere that we have. So this is one way that we're really seeing attackers really leveraging this. And it's kind of, it's taken away the barrier to entry. There used to be something called script kiddies, which I guess there still is, but basically the barrier to be an attacker, at least at a basic level, has gotten much reduced. So you only really need malicious intent now. You don't really need this great technical skill, although obviously in some of the more sophisticated attacks that definitely helps. But I want to talk about one other one, and this is kind of AI as an evasion mechanism, or polymorphism. And this was kind of theoretical until a while, and it's kind of very rapidly in the last couple of weeks become very, very real. So I'm kind of glad this worked out well for my talk that I did this. But basically, all it means is that typically what would have an NPM package or something that has malware inside it. That malware gets installed onto a machine, onto an environment, whatever it is, and it runs, and that's how we deliver malware onto that environment. This idea of kind of polymorphic malware is that instead of delivering a malicious kind of package, we deliver a malicious AI model, or just even an AI model that is able to create specific malware for that use cases. So the scenario where this is a benefit is that we can create malware for an environment that we know of. So when you're downloading malware, you typically need to fit into the criteria that malware is trying to deliver to you. So you need to be using sometimes the correct operating system or the correct tools or anything. If you can deliver an AI model onto someone's machine, then all of a sudden it becomes a whole lot easier to actually deliver and create that custom malware. There's another reason why this is very useful is it's completely invisible to signature detection. So typically how we detect a lot of malware is based on their signatures or the hash of malicious software. But if it is able to change itself in a significant way, then signature-based detection becomes completely irrelevant, basically, for this kind of scenario. So then we need to move to something called behavior-based detection, which does exist, and there's great companies doing it, but it's much harder because signature-based detection is what we would call deterministic, whereas you either have this malware or you do not have this malware. It either matches the signature or it doesn't. Behavior-based detection is non-deterministic, so I think this is doing something dodgy, but it's always difficult to be 100% sure. And then all we need for that AI model, all we actually need to deliver as the attacker is a very small package of instructions there. I have a weird polymorphic malware claim to fame. Here is that one time, it was about 2 a.m. I don't know if I was drunk or not, but I probably was. But I wrote a ranting piece about polymorphic malware that made some sense. For whatever reasons, I can only describe as editorial incompetence. That was published in the Financial Times. And then one day, I got a bunch of emails from journalists wanting me to comment about the class action lawsuit against OpenAI that I was involved in, which I had never heard of in my entire life. And then with some research, I found that there was a class action lawsuit happening against OpenAI, and I was named repeatedly in this from this ranting post that I made. So that was here. So if you want to know what happened about that lawsuit, absolutely nothing. I think they deemed me not a credible expert witness. But it was quite funny, because no one talked to me about it beforehand at all. But yeah. Now, some people might say, okay, AI models typically have guardrails in place to stop people from doing malicious things. So let's say we get a model onto someone's machine, then typically there's guardrails in place. If you ask ChatGPT or whatever to create malware for me, it's going to say, no, I'm not going to do that. I'm a good little AI model. But there's lots of ways around this. So the first way that I won't really talk about is there's lots of different prompt injection techniques you can use to try and get past it. The latest one that still sometimes works, but not always, is called a multi-prompt injection. It's where you overload it with instructions and then put a malicious one in the middle. But basically, we're kind of dealing with this cat and mouse scenario, where what I would say is it's not reliable to assume that the models are able to always determine what's malicious and what's not, because they're trained to be creative. They're trained to have what's called temperature, which means their answers will vary. But none of that's important because you can just download a malicious model. So Hugging Face, if you don't know, is the GitHub of AI models. There's various different models that you can use, you can download from Hugging Face. There's one called White Rabbit Neo, and this is a pen testing kind of model. Typically, it's kind of like used to help you pen test, but it has no guardrails because of that. So if I asked it to create malware for me, it will absolutely just go ahead and create malware for me. So the point of this is saying is if we think we're going to get out of this scenario by relying on the fact that these models are not going to do malicious things, then we're not going to be able to effectively kind of change that here. So all we need to start using kind of polymorphic malware is we need an embedded AI model, and we just need some malicious instructions. And this is where things are very convenient for me to here, because this kind of sounded a little bit unrealistic, and it was kind of like a thought, and it was like, how do I get an AI model onto someone's machine that I could use? How do I get that? It would be a pretty big package. But then people started putting them on their own machines. It's bloody fantastic. So if you don't know, OpenClaw is this new open source AI model that their tagline, it does the AI that actually does things. If you don't know what OpenClaw was, it's probably because it was called Moltbot like 2 days ago, and before that it was called Claudebot. I don't know what they're going to be called next week, but it is kind of cool. I will give them that. It's terrifying as a security person. I'm going to get out of the way that I do not think you should use this. But essentially, it can bed into your systems, and instead of just kind of interacting with an AI model yourself, you can put this in, and it can kind of basically become you. It can do all of the things that you can do, and it can interact with you. It can kind of connect to your emails. It can reply to things. It can delete all your emails. All of these kind of things that you want. It can empty your bank account. It can send me crypto. It does amazing things. Now, there's a little bit to kind of understand where this all becomes kind of very easy, is that there's an ecosystem around this where you have OpenClaw, and then you also have something called ClawHub. And ClawHub is essentially PyPy or Docker Hub or NPM, I forgot that one, NPM, like for what they call skills. So a skill is more or less a prompt with extra steps, but it's basically anyone can create a skill that OpenClaw can perform. So you put it up here on this registry and you can download this skill. So if you want OpenClaw to start trading on Polymarket, for example, there is an actual skill that will allow you to do that. It downloads the right dependencies for it to do it, and it labels your OpenClaw to actually do the things that you want it to do. Again, amazing. Can't believe that people are doing this, but they are. We had a look at ClawHub to see how many malicious kind of skills were out there, and it turned out that most of them were kind of just malicious at this point. So there's a researcher called Paul McCarthy, who's the maintainer of a great resource called Open Source Malware, and he did a great write-up about this, where he basically discovered hundreds and hundreds of these skills that were actually just malware. And if you actually have a look at kind of what are the most popular skills, most of them are all malware. And part of this is because the ClawHub ecosystem doesn't have any kind of guardrails in place, so it doesn't scan for malicious activity, even basic information. There's no way of removing or reporting malicious skills. I think there is now starting to come out. But also you can completely manipulate things like the download numbers. So you can just get a bot to download your skill multiple times. There was a security researcher that did this. They created a fake malicious skill, downloaded it multiple times with a bot, and then that just became the #1 downloaded skill on OpenClaw. That was a researcher called Jameson O'Reilly that did that. So this is kind of where we're at. And now if we go back to what we need to kind of have for our polymorphic malware, is that all we needed to have is basically an embedded AI model, which we now have, and then malicious instructions, which we can now create and deliver and do it. So this whole idea of being able to create malware on these AI systems kind of went from theoretical to very quickly something that we can actually do. And if you're wondering, what is the malware that's on there at the moment? So I had an interview with Paul about this. This is my last plug on my podcast, but Paul came and talked to me about this. Is that there's kind of the dumbest malware available on NPM at the moment, where it's just kind of downloading worse malware. It's just kind of downloading instructions where it's telling you that, oh, if you want to interact with Polymarket, you need this dependency, you need to download it here, and that's malware. But it could get very, very interesting, and you just kind of know that there's a room in North Korea of APTs just trying to figure out how I can get this to do very malicious things and go under the radar. So it's a terrifying new world out there, but it's definitely not getting easier for us. And whilst I sympathize that OpenClaw is kind of cool in what it can do and a progressive technology, I'm very much not going to be a fast mover on this one here. So I want to talk about switch it up now. So I've been talking a lot about how attackers are using malware and what we're seeing out there in the wild, but now I want to talk about how we can use AI to actually detect malware. And because this has been a really cool project that we've been working on. So just a little bit of, if we want to detect, when we talk about detecting malware, people think that it's kind of very similar to detecting vulnerabilities in code. So detecting a vulnerability in code is generally deterministic. So for example, if you have an SQL injection vulnerability, you either do have an SQL injection vulnerability or don't. Here, you very much do have an SQL injection vulnerability. Where malware is non-deterministic, meaning that there are patterns that match malware, but it doesn't always mean that it's malicious. Now, of course, you can have the argument of determinism of whether or not the SQL injection can access sensitive data or how severe it is or areas like that. But just generally, in rule-based pattern matching, which is typically good and what we want for code detection, it's deterministic. And this here is just some kind of, well, it looks like malware. If I saw this in the wild, this would definitely look like malware, but it's not actually malware. There's legitimate reasons of why you would want to obfuscate code like this. So that means that detecting malware is very difficult to do if you're just using rule-based. You still need to use rule-based, and the rules will be things like, are you downloading anything from an external server? But there are legitimate reasons why you might do that. Is your code heavily obfuscated? That's dodgy, but there's legitimate reasons why you might want to base 64 your code 7 times. I don't know. I haven't thought about it, but you might, you know. So there's all these kind of things. And when we deal at the scale of places like NPM, which has 40,000 packaged versions uploaded every day, then even if you have a small false positive rate, it becomes unsustainable. So what we decided to do is we were kind of using traditional kind of scanning methods mixed with AI to actually identify malware in the open source supply chain. So this is kind of the secret sauce, although it's not really new, and we're not the only ones that are doing this. In fact, there's an amazing ecosystem of great researchers like open source malware, like Socket, like Aikido, that are doing this. But essentially, our method is that we scan every single package that comes into places like NPM or the VS Code Marketplace or Maven or PyPy, and we scan it with traditional tools, like traditional meaning rule-based tools, not traditional as in bad, just traditional as in rule-based, and we identify any patterns that could be malware in that. So that may be certain functions that you're using, could be calling external domains, it could be obfuscation, as we thought. We look for those indicators, and then we provide that with a whole bunch of information to an AI model that has been kind of trained or customized to deal with that. If you want to know a little bit about the model that we use, we actually started off trying to build our own model because we wanted to be cool. We immediately thought that was actually a terrible idea, and now we just use GPT because every time they bring out an update, we get a free update. And then we validate that with our LLM, and then we get a human to kind of do the final check in most cases. So what we typically get, we will get kind of different results where it's either definitely malware, or it could be malware, or it might not be malware, but it's worth a check. And so we get all that and to have a look through them. But we're also looking for other things too as well. So for example, does your repository match the name of the package? How many dependents have you do you have 100 versions all at once? So all of these are kind of non-deterministic signs that make it more likely that it's malware without actually having to without having to build rules for all of this. Or other things, spelling mistakes in there, which I guess, or just names being wrong. These are some of the things that we've found regularly on there. So at the moment, we find about 6,000 malicious packages a month. The vast majority is still on NPM, with the second coming in at PyPy. But we're also seeing a massive increase in places like VS Code extensions with things like the OpenVSX marketplace, which is if you're using Cursor, there's a separate marketplace for it. There's a lot of malware going on in those. So I'm almost out of time, but what I thought is for the last 5 minutes, I would just talk about some of the fun malware that we've found and do some of the greatest hits. So the first is the stupidest malware that we've found, but also it's kind of great. You'll understand why. So this is from a North Korean APT, and we found it in this file here, the index.js file, and we got a strong indicator that this had malware in it, but we looked at it and we almost marked it as a false positive because we're like, there is no malware in here. In fact, there's nothing in here. This is just something. But then we didn't realize they had used the stupidest obfuscation method in the world, which was the scroll bar. They just used white spaces to push the malware off screen. And so this was the actual malware here. It was calling this domain, doing dodgy things and downloading it. But why I kind of loved it is that it was so stupid that it almost worked. Like there's lots of other methods out here that you'll see about obfuscating it, but this one was great. And it did everything that you expected North Korean malware to do. It was basically just trying to steal crypto and install backdoors. So that part's not that interesting, but yeah. The biggest potential impact that we had, so this one was from the cryptocurrency Ripple. So there's an official Ripple SDK. And basically, if you want to create an exchange or deal with cryptocurrency, at some point you need to communicate with the crypto ledger of Ripple. How you communicate with that ledger is that you basically should use the official SDK, or at least it'll be a whole lot easier, that will help you do that. So this is a very popular package. It's got 130,000 weekly downloads, so it's not that it's kind of like crazy impact across all of the JavaScript ecosystem, but it is that the 130,000 people that are using this are dealing with currency, so it's quite high value that we're talking about. And this was actually the malware that was found in it here. It's fetching a payload from this dodgy as domain. So we actually discovered this. It was, again, a developer access token that was compromised, that was stolen from an attacker. They then did that. We reported it to Ripple. Ripple remains one of the best companies we've dealt with in terms of like disclosure, in terms of within a few minutes of reporting it, which was 2 a.m. for their time, we already had like a war room set up with them and communicating with them. So they did a great job. And we actually managed to, this was all fixed within about 40 minutes. So we managed to kind of prevent any big breaches coming from this as well. And so basically what they were doing is just creating this function here, check validity of seed, and then you can see some of the interesting things like private keys and that they're sending via that function. And yeah, there's some, once we kind of download the actual payload of that, there's some other things that are going on. But again, don't have time to go too much into it. And then lastly, I want to talk about the most beautiful malware that I found. This one was like, or that we found, sorry, that this one was quite interesting here. So this was in a package called OS Info Checker. I know this is quite small, I will make it big, but basically on line 4 here, we have this decode function, and it's decoding from base64 this one hard-coded string. So we got a strong indication that this was malware, but again, this one left us scratching our heads a bit because we were like, where's the malware? Like, it's weird that we're decoding one string with base64, but it's not. But the one thing we noticed is that the number of characters didn't like match up to what we were seeing in terms of file size. So what we did is we actually had a look inside a Unicode viewer, and behind that string, so we have that one string that you could see, these are all Unicode PUAs. So these are characters that you can define in your project. So they're undefined and unprintable until you define what they are. So when you run this project, then you can actually will get back that this here are all Unicode characters that result in a payload. So that was like very interesting. This was the first time that we had discovered Unicode characters. Unicode stenography is actually It's a couple of years old. It has been used in other breaches, so it wasn't like the very first time that it was used. But then once we got the payload, we saw this here, which was a base 64 string, which seems dodgy. And we looked at that, and that was going to a Google Calendar invite. Now, Google Drives and Google Calendars are actually used quite a lot because it's a trusted domain. And so we were kind of having a look here at that. So then we went to this Google Calendar invite, and we found this here, which had another base 64 string in the title. So we decided to uncover that base 64 string, which finally gave us an end payload of the malware that we're doing. The end payload, not that interesting. It was more or less doing the same things that you would expect of trying to steal cryptocurrency, trying to install backdoors. But I loved the fact of how much effort they went to in actually trying to hide this. This was first released in March of last year. There was another version of this in September that was released on the VS Code marketplace that was named GlassWorm. This is actually the same malware. It wasn't named GlassWorm by us. It's neither a worm, but I'm not going to get into that argument right now. But I'm right on time, so thank you all for checking it out. I'll be at the Aikido booth. I appreciate you staying here.